All right, good evening, everyone. Welcome to, what is this, the second ETH65 event? Yeah, so the first one was a Tokyo pregame, ETH Tokyo pregame. A couple of us here actually went to Tokyo, and we ate some sushi and did some saunas, and maybe we built a few things as well. So we're taking back some of our learnings and sharing some of the things we already know. A few of you know me as organizer of building the network state and part of network0.vc. So tonight I'm going to be talking about what is a network state, how do you make one, and since we have two speakers that are speaking about account abstraction and identity and that sort of thing, I'm going to tie in some of the identity parts of the network state as well. So thank you all for coming out, and yeah, we'll get started with the big question on the screen. What is a network state, and why won't the guys with guns be able to stop you from creating one? Yes, that same question. Okay, so in international law, in the Montevideo Convention of 1933, a nation state was defined. And a nation state is defined, and this is what the basis of every nation state which is recognized internationally today, is it having four things. The first is a permanent population. The second is a defined territory. The third is governance. And the fourth is the ability to do diplomatic relations with other nations. Okay, so in the network state world, the idea is a little bit different than a traditional nation state. But in the effort to be very clear on what exactly a network state is, I've taken what I think is the intention of this definition of a network state, and I've updated it for the network state. So network state is a digital first population with defined resources, also with governance and diplomatic representation. So the main differences here are in the first two. So instead of a permanent population, you have a digital first population. So you meet in the cloud, you're a network, and you're not a permanent population, you're actually an opt-in population. So you opt in to the network state, and you can leave the network state if you want. And if your governance allows it, you can even get kicked out of your network state. So it's an opt-in, opt-out state rather than your classic nation state. The second prong is defined territory. Now, in 1933, there was no such thing as digital assets. There was no such thing as the internet. And I view defined territory as really a proxy for resources, because back then, resources are land. It's the things that you can get out of land, whether it's houses or gold or oil or whatever. Basically, your resources are within some bit of land. And so I view that as like a wrapper proxy for resources. In the digital world, let's just call them what they are, resources. And they don't need to be land-based resources. They can be digital resources, like Bitcoin. And they can actually even be your citizens' skills and network and influence. And so the citizens of your network state may actually be the most valuable resource that you have. Third is governance. I don't think there's much difference here, although I think network states will run new experiments on governance. We have, the classic, liberal democracies and monarchies and all these things. I think we'll see maybe a lot of new experimentation with digital technologies around new types of governments, especially in an opt-out system. For instance, one of the oldest decentralized technologies, I would say, is the US government. It was designed to be decentralized in a day when there was no internet and you had limited communications. And it was designed with certain checks and balances in place, which over time, maybe it needs some updating. In the modern age, we've got new tools that we can update with. And the opt-out nature of network states actually creates a new check on power that just wasn't possible before the digital age. The fourth is diplomatic representation. So, the most formal version of that is is having diplomats come and establish an embassy in another country, and you can negotiate peace treaties and alliances and all sorts of things. But another way to think about diplomatic representation is that your network state has goals. It's got political goals. It's got objectives that the citizens want to achieve, and the ability to interface with local politicians to make those things happen is also a form of diplomatic representation. So you can also think of a network state as almost like a meta political party, where it doesn't have elected officials and it doesn't have diplomats, but it has it may influence politicians in local countries and kind of coordinate across countries for particular objectives. So yeah, that's my four-piece definition for a network state versus a classic state. And now I've forgotten which slide comes next, so I'm going to take the leap. Okay. Yeah, cool. So kind of the way, I'll just pause right at the last slide and just pause for questions really quick. Any clarifying points here? All good so far? Okay, great. Okay, so the way I think about network states is that they are things that evolve over time. So if you just show up in Singapore and you're like, hey, I'm Tom, and me and Dustin, we're a network state. We're a state right here in Singapore. I think they're going to be pretty upset about that. They're going to be like, what are you talking about? They're going to say, like, what are you talking about, La, right? You can't just go somewhere and be like, yeah, we're a sovereign state inside somebody else's state. So
some people did try doing COVID though.
So, I think the beginning, you have like as many people are in this room, and hey, it's just a club, right? We're just a bunch of people that are, forming this group, this club, and don't worry about us, act blur, right? Sorry for the non-Singaporeans in the room. It's like, how do you translate act blur? It's such.
Just pretend that you don't know.
Pretend you don't know. Yeah, just pretend like nothing's happening, right? It's a great Singaporean term that needs to be exported. In the end, it might look like a massive political influential party that actually has recognition from various other states, perhaps even from the UN. And a great example of this is actually the WEF. Because the WEF has a defined membership, aka citizens. They pool resources, they pay a fee, and they've got a whole program for achieving certain objectives, and they have governance around that. And then they all go out after they've decided their agenda, and they influence the governments of the world to follow their agenda. So in a sense, the WEF is the original network state. Albeit a stretched analogy, but really that's kind of a little bit what the end state looks like. Like that amount of influence can actually turn into state recognition. And there's lots of examples of other countries that have done that before. So that's the beginning and the end. What does the middle look like? Probably somewhere in between a club with a bunch of people hanging out in a room, and then maybe like the middle turns into an international club with maybe physical locations, and then the end turns into this more influential network of members. So the question is, like, how do you get there? How do you start in the beginning, and then how do you make your way through the middle, and how do you make your way to the end? So how to start a network state. So to start off on, I think a lot of people miss this part. One of the important things when you're creating an opt-in society is to have alignment on values. If you're not aligned on values, then you're basically trying to create this new type of civilization or society with a bunch of people that you completely disagree with. And so the very interesting thing about the network state is that it allows for hyper-specialization of values in the digital era. in pre-internet world, we basically, our values and our interests were defined by the block, the area we were born, the neighborhood we were born in, and basically you're just like interested in local sports, and if you were like a weird like radio enthusiast, then you just like did that in their basement and pretended like you weren't doing it. In the digital era, all of a sudden we had access to the internet. We had access to all these like hyper specialization of interests. There's like 2,000 different types of like cat interests that you can get into on the internet, probably even more than that. And you can find people that you're hyper specialized on interests with. But right now we have that hyper specialization of interests. We don't have that really on the values front. And so you're either in a more traditional country where your values are just based on your neighborhood, or you're in a modern city where there's just a mishmash of values all over the place, and like you're basically just constrained to the values of your house. So the network state allows you to connect digitally on something that's a little bit less specialized than interests, a little bit broader, which is values. And you have multiple values, and so you can actually hyper specialize on your particular set of values and form a state around that, and connect that way, and find people all around the world that share that same somewhat specialized set of values. Once you've done that, you want to plant your digital flag. So you figured out which values you want to represent, and you put your flag up and you say, hey, we're here, we represent these values, we're on the internet, come find us, come connect with us. And once you've created an online community, then you want to create meetups in real life and start connecting in real life. And so you may have members all over the world, in Singapore, in New York, in Istanbul, in London, and you want to create these meetups in different cities of people that are values aligned, and start having conversations and discussions and building relationships. Because you really can't start a state without really having a close relationship with the people that you're starting the state with. After that, and you can maybe figure out some goals. So if you're a longevity network state, which seems to be a popular example these days, you might say, okay, if our goal is to like live forever or die, then we might want to be taking these like experimental longevity drugs. And oh, hey, Singapore doesn't really allow us to take those drugs. So one of our goals might be to either change the laws in Singapore that allows anyone to take those drugs, or change the laws in Singapore that just allows our members to take those drugs because they're qualified for whatever reason. They're part of the longevity network state. They must know what they're doing, right? So you can establish some goals. Maybe your goal is like getting Bitcoin as like a accepted currency, and so that's a goal of your network state. So once you've got these goals in mind, then you're going to want to pool resources in order to make those goals happen. And so if you're a longevity network state, maybe you're all getting some research drugs researched, or maybe you're getting them imported. Maybe you want to have a health center to help all of your members be more healthy and live longer. And so you're going to have to contribute funds in order to make these, or other resources in order to make these things happen. Does anyone know another word for this? Pooling resources for public good. Anybody? It's called a tax. So there's a reason that taxes are charged, but in the network state world, taxes are voluntary. They're not just charged to you based on wherever you live. So a network state, if it really wants to be able to charge taxes, it has to provide a public good to its members that is worth paying those taxes. So this is a check on that on that power, right? Whereas the nation state, which you're forced into, you have to pay whatever taxes they say. You don't really have a say in the matter. In the network state, you can just leave and not pay the taxes anymore. And when you're in a free market, then you'll be a lot more efficient with how you use that tax money and what value you deliver with it. Okay, so you've got all these things together. What else do you need to be a network state? You need citizens. You can't really be a state without having residents, without having citizens, without having people. without having humans, although who knows, there might be an AI network state, but I think most network states are going to want to constrain themselves to just humans in the beginning. And this is where identity comes in. And I'm actually going to talk about a little bit after this slide, I'm going to talk about that a little bit more. But to like finally establish what your network state is, like you've got your values, you've got your goals, you've got your resources, you have to define your citizens. You have to come together and say, you know, here we are. It doesn't have to be, it can be zero knowledge, but it at least needs to be like, here's a list of validated humans, and we're all citizens of this network state. And we're acting blur, right? But internally, we're calling it a state. Well, the next step from there is to recruit new citizens. So if you've got a flag planted in Singapore, London, New York, grow the pool in those places. Find other people that are aligned, have them come in, have them join, have them pay taxes and get the benefits of doing so. Start expanding to new cities, different locations around the world. Set up a new base in Ho Chi Minh City, in Tokyo, in Austin, in Chicago. Anywhere where you can find aligned people to join your network state, you should grow and recruit those citizens. And then that becomes really the flywheel that you're building on. Is you grow the population, you acquire more resources, whether it's digital, maybe it's a plot of land. Now, land is not the defining feature of a network state, so if they take the land, it's fine. It's just a place we hang out. We can find another place to hang out. And then if your goals are accomplished, you know, you might want to have a governance process to figure out what new goals you might want to accomplish. As you grow bigger and your members are more influential and they're a larger group, you basically become a political bloc within the country that you're in. And this is when you can start really influencing local politics. So your network state might actually stand up or at least heavily contribute to the campaign of a local politician that's aligned with the goals of the network state. And then the ultimate test of the network state is to get some sort of recognition. This doesn't mean that you're a UN recognized member state, but the ultimate test of recognition is whether or not you can get a carve out for your members. So what I mean by this is, if you look at the large religions of the world, they've all gotten carve outs, exceptions to the local laws for their religious beliefs. And so if you're a network state and you're able to convince a local government to carve out an exception for your people based on their beliefs, and not necessarily religious beliefs, but secular beliefs, then you actually have recognition from a state. And from there, it can only grow. You can actually be recognized as a state by that state or by other states, and from there you can possibly make it to the UN or something like that. But I think the real test here is whether or not you're able to get the exemptions based on the beliefs of your citizenry. So yeah, that's briefly a short TLDR on how to start a network state. I hope this has been clarifying for people as to what a network state can actually look like, because I know it can be a nebulous term sometimes. And then just real quick on identity, I want to hammer home this point. Your citizenship in a network state is a property of your identity. You own your identity. Your identity is self-sovereign. You're a human, and you have an identity about yourself, right? In the nation state, your identity, your ID card, your passport, these are actually state-issued identities, right? They're actually a property of the state. The state owns that identity, and they're not yours. If you leave that state, they take that back, right? So in the network state world, your identity is yours, and the network states that you're a part of, or the nation states that you're a part of, are a property of your identity, right? And so just like in the Bitcoin and crypto world, you know, your private keys are your digital assets. In the network state world, that becomes part of your identity as well. And you can take that with you. So you can leave a network state without having your identity revoked. and that's really, I think, one of the most critical and defining points of a network state. And so I think we're going to hear from a couple of speakers tonight about how to make that identity and account management a lot easier, because writing down a bunch of seed phrases and betting your entire life on that is probably a bit scary to all of us, even if we're experienced. And with that, I'll give you to the next speaker. Any questions?
So, thank you very much. It's a very noble endeavor that you are basically progressing this idea. What are the next steps?
What I'm looking for right now is somebody who's actually making a network state. So there's a lot of early things out there that look a lot more like startup cities, which are also very cool. But startup cities are defined by their territory, and so they necessarily are not network states. Now they may be part of a network state, and so I would say we're very, very early in this idea. When I first encountered DeFi as a concept, it was like, Salt and ETHland, and it wasn't even called DeFi yet. And I think we're like before that, where we're still trying to figure out. This is like an attempt at defining what it is and how to make it. So I'm looking for the folks that are going to start the first one, and then over here, and then so once we've figured out who's going to start the first one, then we can start refining it and recruiting for it and figuring out how to grow it.
So you mentioned organized religion. What is the difference between a network state and an organized religion?
That's a good question. So organized religions don't have a defined population. So anybody can just self-identify as a Catholic or Jew or Muslim or Buddhist, right? So I think that's like they failed that first test of having a defined population. So if they were to do that, I think the Jewish religion is probably the closest, because if you're Jewish, there's a country called Israel, which if you are in fact Jewish, and there's like a test for that, you have to be born of a Jewish mother, so Jewish by blood, you'll get a passport from that country. So Israelis are in kind of a network state because they're you can get a membership if you pass their test. But other than that, they otherwise have many properties of a network state because they pool resources. They're not defined by land for the most part. They're geographically dispersed. They have some form of governance to manage their pooled resources, and they absolutely influence the local countries they're in. As I mentioned, they've got carve-outs for their religious exemptions. So in a sense, you might think of a network state as a secular religion. That's another way to think of it. But I think like having that crucial citizenry, like a defined membership, I think that's a crucial part of it, because some religions claim to have represent certain values, but because anyone can opt in, the members don't always represent those values. Any other questions?
Yeah, to me it looks like very similar to a lot of things that we've been going through. Discord, there's a lot of members in Discord, and a DAO. The only thing you don't have is the political influence. So there are
You also don't have organization.
some do.
You need to show me.
Some Discord group.
I think like governance organization is like I think that's going to be a very experimental area, because benevolent dictatorships work when you have an option to exit. If you can leave if the dictator is evil, then it's a check on their power. So we might even actually see that dictatorships being the best form of network state governance. What's that? Mafias? What do you mean?
Secret societies.
Yes, yeah. Yes. Did you have a question?
Yeah, like
DAOs are nearly a network state, right? There's only a few features left out of your 10 criteria. So are they evolving towards becoming network states?
I think one of the potentially yes. Many DAOs are pay to play, right? So there's absolutely no values alignments. It's just like you buy a thing, an NFT or a token or whatever, and then you're in. The Moloch DAOs are a little bit more like proposal based, but I think you see a complete lack of like real organization or governance in a lot of those DAOs. So yeah, in a sense, I think you see that, but like a lot of them seem relatively aimless right now. And so I think the values alignment and objectives and goals in the real world is going to be important to that. But yeah, I'm sure we'll probably see some iteration coming out of that. Like if you look at that as like version like 0.1 or something like that, then network states might be like version 10 or something. Any other questions over here?
Thanks for the very interesting overview.
Mm-hmm.
It's a classic state, it's a network state.
Mm-hmm.
So with the classic state, the government has a compelling reason to protect its citizens, right?
Yep.
Cheaper education, healthcare, what's the most compelling reason to organize a network state?
Yeah, so as I mentioned, your network state needs to provide some public good beyond what the citizens are getting from their local governments. If you try to replicate what local governments are doing, then people are just going to basically be charged double tax for, maybe they can make a better education system, right? Or maybe they can make better healthcare, but it's going to be marginally better, and they're still going to be paying for, well, unless in the US you won't really be paying, but you're still going to be paying for the local services. And so I think a network state, when it starts out, it probably wants to focus on services that the existing governments aren't providing. So you use the word healthcare. Healthcare is actually, the word health is actually a misnomer in literally every country in the world. Because what they call healthcare is actually medicine. It's solving problems, medical problems that happen, and it's not preventing them. So in the longevity space, it's about not increasing your lifespan. Like yes, you can stay alive for a long time, but you'll brain dead and you have no function with your body, right? So they focus on a metric called health span, which is how long can you be healthy for. So if you live to 100, but you're basically in a wheelchair from 50, then what's the point, right? So with longevity, it's like, okay, well, let's be healthy until 100 or beyond, right? And so I think the reason that the idea of longevity network states has been resonating is because you can essentially pool together resources to provide actual healthcare, not emergency healthcare, but preventative health span increasing healthcare to your members. So that's an example. I think the point here is that when you start a network state, you've got to add some value beyond what you can get from the local states. Once you get to the point of being able to carve out exemptions and maybe even like define a little enclave within a country, then maybe you can start to replace the local services if they're inadequate, and you can get maybe some tax exemption from the local government for that. But I think having the influence to do that is going to be a long way off.
So do you foresee like the kind of collision between that and DeSci, where DeSci is trying to fund things that a lot of governments don't really want to touch?
Yes.
And you see alignment there where maybe the longevity network state can go, we would like to be able to do research on these experimental
Yep.
events and stuff like that.
Yeah, absolutely. I think that like network state jurisdictions will enable research in DeSci that maybe wouldn't be able to happen otherwise, from both a funding perspective and a regulatory perspective and a couple of other perspectives.
Do you think micronations are kind of a type of network state, or they're different?
It's a great idea. No, they're defined by their territory,
Yeah.
so they're not on their own a network state. However, a network state might aggregate a bunch of micronations together and form a network state that way, right?
And
So the problem with a lot of micronations is that you've got a relatively small or corrupt or temporary government. And so, there's been like various programs over the years to get citizenships or residencies or special economic zones, and these programs, they basically get canceled or rugged or changed within years of being implemented. And so I view the role of a network state with the micronations is basically, hey, this is if you want your micronation to be like part of our network state, you have to provide these residency or citizenship or whatever services to all of our citizens. And you're not the only micronation here. So all 20 of you need to do this. And if you stop doing it, well, you're just going to get kicked out. There's 19 other people that are willing to take your place. So I view the network states as a way of actually aligning the micronations to the benefit of the network state citizens. Anyone else? Yes, one more?
So you are here talking to us about network state.
Yep.
And then we are here listening to you about network state.
Yeah.
And then we are here under the umbrella of the ETH65 meetup.
Yeah.
And we are bounded by common interest in crypto.
Yep.
So does that qualify us in this room to be part of a network state? Would you consider us a network state?
That's a good question. So with crypto, everything is open, but there's no filter, right? There's no citizenship test, right? And so blockchains, cryptocurrencies, they're open networks, anybody can join. And I think they're the infrastructure that is needed to build network states because, like I said, your identity is yours, not the state's, right? So you need that built on decentralized infrastructure. But the state itself, I believe, should be gated. And you should have a test for citizenship, right? It shouldn't, if you let anybody become a citizen, then your state is going to have very little influence because anybody can join, right? You want to be exclusive and build up, some sort of something to stand for, right? And so people in crypto are relatively aligned on a lot of these ideas, but they're not totally aligned. And just look at the divide between Bitcoiners and Ethereans as an example. You look at people are like forking or like building alternative Twitters, right? And the idea was like, oh yeah, we're gonna have like one protocol backend and then like lots of different like front end interfaces depending on like what tribe you belong to. Well, it turns out that not only do people want a different front end interface for their tribe, they also want the different backend. So you have like Nostr and Farcaster and Lens and Blue Sky and all these like decentralized Twitter protocols. Everyone's choosing the backend based on their tribe. And so yeah, I think like. Yeah, anyways, like you need to have the open technology is very important because that enables the option to exit, but your network state should be gated and you should have a test and stand for something. Yeah. Cool. Anyone else? All good. Okay, great. Thank you guys for coming out and listening. And we have our next speaker over here. Yeah. Cool.
Cool. Awesome. I think we get started. I thought it was like 10, 15 minutes. I will try to be more brief. But hey, I want to thanks you guys that we were in Tokyo and was at Taipei, and then like we connected. We said, oh, there is an account abstraction meetup. On Friday we say, yeah, let's do it. I think was an awesome idea. And I've been here 3 days. Every night there is something, and it's just amazing how the Web3 community is active here in Singapore. And my talk. So I thought about like doing something different, right? Like we spoke, the past days on Infura and more Truffle, so the more developer tooling infrastructure. But I asked myself, what is relevant for account abstraction and what is something that, you guys should take home and is actually useful. Why we're actually here, so to build sustainable and regenerative solutions. So we need to kind of open up and have this, what I'm actually trying to iterate is called permissionless innovation. So we literally give the instrument and standards to the developer community to build whatever they want, right? So it's not just one company that actually provide and create those features for the community, but it's actually the community contributing to build cool stuff. Everybody kind of know what Metamask is, but also the interesting fact that we have both extension and mobile, and today like both extension and mobile are interacting through like the app's APIs, and those are also fully standardized. Then in theory you can also use if you want to build anything else in the wallet ecosystem. Those are kind of like the three pillars in terms of developer tooling. So literally, snaps think about extensions that you are building as a developer on top of what MetaMask is today. But the cool things about Snap is that whatever snap you're adding to your extension today is coming like basically as 0 permissions by default. Means everything that Snaps is interacting with your extension, you as end users know about. And this is something that we actually care about, because a lot of like, let's say, a relationship with extension and different extension, like the end user never really know. This is how we're basically distributing snaps today. So you publish the snaps on npm.js.io, and you deploy the snaps. You can invite other people to download, and everybody can invoke your snap. And this is actually quite cool, because it's similar to an extension kind of like way to distribute snaps. This is what you see in Flask setting when you have multiple snaps. So you basically have all the snaps that you installed. And it's actually quite cool, because you can both revoke access, disable, put in standby, and you see also the cron jobs that are happening on the background. Cool. So those are the use cases that I mentioned about. It's quite interesting, because I touched on for example, on API, on push notification snaps, on Node EVM snaps. The people build like a Starknet snap, a BTC snap, a Solana snap. It's actually quite cool what is happening. But account abstraction snap is also like a big use case that people can actually do account abstraction use case on top of what MetaMask is today, and also identity. I'm quite interested. We saw like back in Bogota, they built a lens snap. Basically, you are interacting with different like DEXs and decentralized social media, and you literally had the snap, and you were able to understand what and when. Basically, you knew where you were basically there. Communication snap is also quite cool. Like some people build some WhatsApp fully on a snap. They also build, I was actually quite interesting, an arbitrage bot snap that was doing like, basically when event was triggering, you get notified, and they basically integrate push notification APIs, and and that was actually quite cool, because when this event was triggered, you get a notification, and basically the snap bot was executing the transaction, and it was quite powerful. But I think like there are unlimited use cases here, right? And account abstraction was one. We saw actually in Tokyo a couple of like solutions were around like gas fee and paymaster. There were like one that also did revoke access. They kind of built a MetaMask Lite version on top of Snap that was actually quite cool. So the things that I kind of mentioned before is that basically snaps are just an extension, and today they are similar. They're basically like they are working like an external independent app that is connected with your extension, and they can. So you have basically all the world of external APIs. So you can interact with any API out there to build your snap, and that's quite cool. And those are kind of like the API we added during the day, but costume logs, notify users. Notification is quite cool, because you get on-chain and on your direct machine notification. So whatever events is triggered, you get this notification. And one big ask from the community is also having a UI, basically UI extension of what the extension is today. So think about you're building a notification, and you want to get automatically a extended MetaMask UI on top of your extension. But we're working on that. Like actually, we're working on pushing like snaps on stable, so that also end users can actually like take and download those snaps and use basically like MetaMask with more functionality. Cool. That's basically I kind of like mentioned Flask, and Flask is it's the canary version. It's literally like the staging version of a website. We basically built a library also for Tokyo for basically having a snaps guide with bunch of like resources there. There are also like example snaps that I will not go through. I actually put it in the presentation I can share later. And there is also a monorepo. So basically you don't need to build the snaps from scratch. Use the monorepo, and you build the snap on top of this. And that's what we're seeing a lot in different hackathons that's happening. The Starknet app is quite cool because literally you do like a Starknet transaction on top of Metamask, and this is actually quite cool to see a non-EVM snap. Transaction each side is also very interesting, and yeah, there are a bunch of examples. The BTC snap is quite cool. Starknet I mentioned, and transaction each side is also like interesting. We mentioned that. Ecosystem-wise, yeah, so we launched a couple of, was 6 months ago, the Metamask Grants DAO. So if you guys have any idea, or you build a snap, you didn't know like what to do after you won the hackathon, just submit a proposal. This is an employee-led DAO. It's quite cool because everybody can vote on your proposal, and it's a couple of millions a year that we want to support like all the Web3 ecosystem. And yeah, like if you guys didn't see us, we also organized this ConsenSys Connect during, and Next Stops is also doing a big one during ECC. It's a bunch of like developer workshop panels, and basically a day event focused on builders. Cool, yeah, that's me in a nutshell. And I actually didn't present myself, but yeah, I'm part of the developer relation team at ConsenSys, and I've been for the past decade in developer communities. And I'm just literally enjoying like supporting Hackathon and online and offline developer onboarding in the Web3 ecosystem. Cool, thank you so much. Awesome. Any question out there? I know that it's a lot of content for like, I don't know, 10, 15 minutes, but yes.
So I've talked to some wallet devs, and they're competitors to Metamask.
Mm-hmm.
They're concerned about Snaps because Snaps basically becomes like a platform that everyone starts building on. And as competitors, they're like, then should we be building Snaps instead? Or if we build Snaps, how do we even compete? So
It's a good question.
How do you feel about like that in the wallet space where
Yeah.
you're becoming a platform, and in a way, if you're the platform, choices that you make in Metamask also affect what kind of Snaps can be built as well?
I mean, there are two ways to answer kind of like, so first, snaps exist because we have, I mean, on extension we have something like 850 open PRs or something, and we are not able to keep up with innovation and what people want as features. And that's why we said basically like we provide this infrastructure and people build. The second thing is that I think like the natural progress of a wallet is kind of like having the community build a top feature on that. See like other business models. See, I mean, who like WordPress? I don't know. I'm not a big fan, but you know why they kind of like really like grow up like was because of their plugin ecosystem. And the one thing that we need is standardization on top of those snaps. I think like some companies will come with some kind of standard snaps that you can also have for other wallets, so that actually the user is directly having a snap and is automatically like reachable on other wallets. And that's I think something kind of natural that will come. It was the same with like all the NFT API and metadata, right? When we had OpenSea and you try to scratch like metadata from NFTs, there were like a shit show on going to Rarible and pushing those NFT there. And then and then came all the NFT standards, and I think like it will come is exactly like the same for snaps in the future. Oh, nice T-shirt.
Thanks. How does the Account Abstraction wallet look like on top of Metamask snaps?
I mean, like the example right now, they're quite trivial, right? We had an MPC snap. They were doing account recovery, basically like having the snap in multiple accounts. We're able to doing like an account recovery. Then we had was like a revoke access snap that you were actually able to directly. Then there was also a snap that we were basically create a light account. So the snap was basically creating an automated seed phrase for you. That was actually quite interesting. I think that's it. Like it was called AS snap that was doing like a specific transaction. So the owner, you were defining, I don't know, like 3 or 4 wallets. Basically one wallet was taking care of the gas fee. So basically some kind of like paymaster.
One follow-up question. So keeping Snap aside, how is Metamask thinking about account abstraction?
There is no official way how to think so. Like there is no public statement. Like what we are telling people is that we want to enable account abstraction use case through snaps. So that's kind of the official. Then there are a bunch also like other initiatives, but this is probably like the most interesting. Like we are also caring a lot about the end user. Our mission is basically provide the end user with a really like powerful, and the end user are keeping their information safe, right? And the question is also, if you're starting to do email recovery, yeah, you can ship that on production, but is it actually the right way to keep your end user fully safe? It's also a big trade-off between those, like how to onboard a users versus having a user like fully aware of what he's doing, right? But I think there will be different type of audience, and I think we need those use case for onboarding the next billion users. We need email recovery. We need to like light accounts for doing that. Yeah. Cool. Any other questions? Yes.
So I'm thinking in terms of security for snaps. So because it's something that community builds. So like in terms of crypto, phishing and like scams or something is very common. So is that something that you're concerned about?
Yeah, I mean, yes. So this is a very interesting question, right? So we're working, for example, there are a lot of snaps being built. There are a lot of like different like partners building snaps that we want to kind of like say, okay, those when we ship to stable, those are like the 50 snaps that we want to ship first because we actually like work with these partners. But at the end of the day, like we want also like the community take care of this kind of review and review cycle, right? And it's very interesting. In the security side, we have a lot of like companies that build a snap with their, I don't know, like transaction checks or phishing like attacks. So any accounts that you're transacting with you basically have a snap that is double checking what you're doing. I think this is also quite cool. But in terms of like security on the side, like I think like it will be hard to control that side. What we can control is having like a proofreaded and audited layer where people can actually build a snap on top of this. This is what we're trying to do right now. Yeah, we're getting fully audited.
Okay, so it's something like there's an official checked and audited marketplace. There's the other one.
Yeah, it's
you can sideload and
The idea is, I mean, it's very difficult to control this, right? But what we can say at the beginning is we have those partner snaps that are actually built, and we know they're kind of like, they took their time to do it. And then it will basically like much more broader community snaps that are like also self-reviewed by the community itself. And I think like there will be like, for each use case, we will see also like very similar snaps built by different people, and the end user will decide what like you're doing with plugins today, right? You type through 3 like also Chrome extensions. You are based on reviews and stars and downloads number, these kind of things. Yeah. Cool. Awesome. Thank you. It's more than 10 minutes. I hope everybody is not sleeping. Awesome. Thank you.
Cool. Just a little bit about the group I work with. We're privacy and scaling explorations. We work a lot on zero knowledge proof and primitives and experimental applications of those. We also work on some other things such as scaling, which I'm more going to be talking about today. You can find out more about us at the QR code above. And if you have any questions, you can follow up with me afterwards. I'm also, my slides, I'm going to have a lot of links. Don't worry too much about taking pictures. I'll share them. Dustin has them, and he can share them out after the presentation if you want to dig in. Cool. Awesome. So anyways, we're going to cover Bundled by BLS Wallet. I'm Jacob Caban-Tomski. You can call me Jake, and I'm a developer at Privacy and Scaling Explorations. Cool. We're going to go over, I'm going to talk a bit about ETH Tokyo and ETH Taipei. I just came from ETH Taipei. We're going to go over kind of some things about the hackathon, and then 2 projects that I really liked from them. We're then going to dive into BLS Wallet and its kind of implementation of account abstraction, and we'll talk a lot about BLS signatures in ways we're trying to essentially further scale L2s even further than they are now. And then finally, we should have some time at the end for questions. That's me at ETH Denver, wearing my fancy mentor costume. I do a lot of Ethereum hackathons, both as a hacker sometimes, but a lot of times as a mentor, helping hackies kind of build the best thing they can within a weekend. I've also in the past done a lot of game hackathons like Global Game Jam and Ludum Dare. It's a lot of fun. So definitely, it's really fun to get engaged in these different areas of the local communities and learn a bit more about the problems they're really interested in solving. All right, ETH Tokyo and ETH Taipei. They're really good. This is me with some of the mentors at ETH Tokyo. We actually had a really solid team for that, almost like round-the-clock coverage for hackers. Had a lot of really good questions, and yeah, it was just a really positive experience. I also did ETH Taipei, which was also really cool, a bit of a smaller hackathon, a bit more intimate. And there was also a lot of really good deep technical talks. So if you get a chance to go to either of those when they probably happen again, hopefully next year, can highly recommend. Really good communities in both spots. I wanted to highlight 2 projects related to account abstraction that I thought were really cool. One of the biggest ones was ZK Voice Key. And this essentially was a built on top of, I think it was ERC-437, and allowed you to actually recover your account using your voice. And so under the covers, it's using a zero-knowledge proof that's tied into a like ML voice identifying algorithm. And so basically, if you can imagine if you lost your device or your seed phrase or your private key was stolen by someone else, you would before, with your wallet set up your voice key essentially to recover. And then you could go into any other device and then use your voice, and assuming it matched up with what you had stored, you could get back your account. So that was a really cool project to see from there. Another one related to social recovery is DeFi San Seviera. I think I pronounced that correctly. And this was basically just like a very basic, once again, ERC-437, like social recovery setup. And there are a lot of products that already do something like this. I think Safe has that capability built in. Argent has the idea of like Guardians built in. But what's really cool about this is they were able to basically build it from scratch in a weekend using a lot of different frameworks and components. So it was just very cool to see someone able to build this kind of a module just very quickly over a hackathon. So some takeaways from me from attending both of these hackathons. Some big ones are that hackers are becoming really good. They're becoming increasingly skilled. They're asking really good, deep technical questions, and they're really trying to pay attention to make the best projects they can and expand their learning, which is cool to see. You still are having a lot of beginners join, which is also good, and it's good to be prepared to help them with really basic questions about Web3 or sometimes just software development in general. So definitely good to be prepared for that if you are mentoring at a hackathon. Tooling and frameworks are getting much, much better. People can build much more complicated projects in much less time. The documentation is much better, so people can more self-serve themselves when they have questions or run into issues. And then one thing that still is sometimes a problem is if there are bugs, like you run into just a weird error and you have no idea what's going on with a third-party framework, it can be really hard to figure out why that is. And it sometimes is hard to get in touch with those bounty people or those third-party teams at the hackathons. I usually recommend you go directly to that team's Discord server, but if you're someone who's planning on sponsoring bounties or participating as like a vendor in a hackathon, highly recommend you have at least one person available, maybe not totally around the clock, but pretty frequently to help hackers, especially on Saturday night when they're trying to finish up. And then finally, the projects and the hackers, they really want some follow-up. What do they do next? How do they expand on their learnings? How do they take this further? Are there any grants or funding opportunities so they can take this project from the prototype they built into a fully featured, production-ready project? And then they're also very interested in employment in the space. So, they're wondering, like, what are the steps that are needed for me to get a job? What are what are people looking for in terms of qualities that they would want to hire for? And so providing that opportunity for like hackers to follow up on, I think would be really powerful. Cool. So for the next slide, we're going to go into the project we're working on, BLS Wallet and Account Abstraction. We're really mainly going to focus on BLS signature aggregation and some novel compression things we do, and we'll go over a couple of features as well. So what is BLS? It stands for, and I'll mess this up, Bon Lin Sacham signatures. And it basically is a pairing cryptography-based signature scheme used in the consensus layer for Ethereum. So this is what validators use to attest to transactions and to sign them. It's also used in Zcash and some other projects. What we mean by a pairing cryptography signature scheme is in normal cryptography, you'll have like elliptical curve cryptography. The pairing-based cryptography, from my understanding, is basically two elliptical curves you're using to do the signatures. One is called G1 and one is called G2, and you're using the points on those. So it's deterministic for a key and message in comparison to ECDSA signatures, which are what we use right now on Ethereum. So for any given transaction or message you're signing and a public key, you will always get the same signature output. ECDSA has a random nonce component that will change it. Let's see here. So yeah, as I mentioned, validators use this sign. They're using a newer curve called BLS 12381, but we have an older curve available in the EVM directly via EIP 197 and some precompiles, BN 254, which you'll sometimes also see referred to as Alt BN 128. This is actually the same precompiles that are supported via that are used for ZK snark verification in the EVM. So there's some crossover in terms of the technologies that are available there. So if you've ever seen someone take a SIRCOM circuit then converting it into a proof on the EVM, which is common in some cases, for example, with ZK rollups, they're using the same exact cryptography and math under the covers. And then we may get in the EVM some sort of newer BLS curves via some EIPs like 2537 or other things that are being considered as well. The diagram on the right is how the actual signature aggregation verification is working. There's a really good article on cryptology that goes very into detail with more about that if you're interested. But really, what my project's interested in from a high level is the actual aggregation. And what the aggregation is doing is it's basically taking all of these signatures that are all 64 bytes apiece, and it's merging them just into one signature. And so the cool thing you can do with this is that even though if you have different transactions or different messages, we can essentially take all of the signature data and merge it just into one. And so the property we really like to use that for is for rollups. So most optimistic rollups, when they send their transactions up, they have to take every single transaction and every ECDSA signature, which is specified by like an R, S, and V variables inside of that, and they have to roll that data up to L1. If we instead were to use BLS signatures around these transactions, we still have that same transaction data, but instead of having all those different signatures per transaction, we can just have one. We still do need one signature for the actual L2 transaction we do as part of these transactions, but we can save a lot of data by taking, in this case, that would be, maybe 128, my math is bad, but a lot of bytes, and just making it 164 byte value. And so this is a quick diagram showing part of the stack we use in BLS Wallet to accomplish this. We have a aggregator, which you would see for ERC 437 as a bundler, and it is able to construct across a bunch of user operations a bundle of operations. You then have the aggregated signature, which is going to be that BLS signature, which is applied to all of those things. So then after this, we actually submit this as one L2 transaction, and it goes into our smart contracts. There's an expansion operation we can do, which I'll talk about in a little bit. And then we actually do our SIG verification on chain. So we're able to run in Solidity code, hey, for these given contract wallets, do their public keys match the signature for what we're trying to pass in? And obviously if they don't, we'll just revert out of all of that and it will fail. So then each of these operations has some actions inside of it, and they actually go through into the contract wallets. And so this would be your actual smart contract that's managing your assets, and have your actual address people are sending funds to. And then finally we call into, say, a DApp contract or somewhere else that actually is going to execute all of this logic. This is also very similar to how other account abstraction schemes work, where you have an entry point that validates, and then you execute against a specific wallet. Cool. Quick sanity check. This all somewhat making sense? Cool.
So if you bundle a bunch of transactions together, at the point of the verification, if one of the signatures, for whatever reason, doesn't verify, is the entire bundle failed as a transaction?
Yes. So we currently do that.
So that's why you have to check it before you send it in, otherwise you're wasting the bundle.
Yeah, we essentially do a revert code if we check every public key. So we pass in all the public keys that we want to verify and the actual payload. If one of those mismatches, we revert out. We do not revert in some cases if your actual operation fails. So you could have a bunch of users have their operations and one fails, and that's okay. But for the actual cryptographic verification, we don't want people passing these bundles in unless the entire thing is correct. Yeah. Cool. Also, this kind of format is supported by ERC-437, which is kind of the big account abstraction spec that most people are building towards now. They have the concept of an I aggregator, which is essentially a separate contract that does all the signature aggregation and verification for you. Our wallet framework right now is not compatible with ERC-437. We're going to have a future version, hopefully sometime this year, that will be. But know that supporting BLS signature aggregation you can do inside of that spec as well. Cool. Let's talk about some other features we can get out of this as well that help improve some of the scalability and usability of these. So right now I'm sure all of you have gone into a DApp, like maybe Uniswap, and you've had to do a swap. And before you do it, you have to approve before you do the swap. One of the cool things we can do with these user operations is we can actually merge all of those into one transaction or one kind of operation. So previously, you might have to do an approve in one transaction, a swap stake, whatever in the second one, and then in the future, if something goes wrong or you just want to get rid of those permissions, you can do a revoke as well. And I think it's approve with like a 0 value or false. And we can also do a multi-call if we wanted to merge all these together into one atomic thing, but that requires a separate contract. With user operations, you can do this all as a series of actions, and they all happen kind of in one transaction. They're atomic. If one fails, everything fails as part of that. And it's just built into this like wallet standard. You can see on the left here an example of how this looks in TypeScript, where we do an approve and a contract interaction all at once by encoding the function. And the nice thing too with this is we don't necessarily have to limit it to 1, 2, or 3 actions. It could be any number of actions as long as we have enough gas to pay for it. The other cool thing we can do is compression. So right now when you are sending transactions with data to Ethereum, like an EVM blockchain, you have to have the gas price inside of it, you have to have the nonce for the wallet, a lot of other details that take up kind of a minimum amount of gas for the chain to run it. But if we're able to batch all of these together, and we have that ability to kind of do certain logic around the transactions going through expansion, we can actually compress a lot of things down to a very tiny amount of bytes, which makes the call data very small and therefore makes the data rolled up extremely small. So for example, we've actually messed around with this using VLQ encoding. The QR code at the top left leads to a much more comprehensive document where we talk about this. But basically, this example is 3 Ethereum transfers and 7 USD transfers. And I forget what the normal transaction size would be, but we basically take all of those and merge them into just 188 bytes of data. And that's what you see diagrammed here. So, for example, this top level one is going to be an ETH transfer for 0.07 ETH. We have to do, this is the start of the hex value, this is the end of the hex value. This is going to be the actual function selector, so this is saying run through our expander contract. And then this data here is what type of thing we're doing, and then I believe it's the amount, the address it's going to, and the address it's coming from, and the address it's going to. And so we can really compress and shrink that data down, and then take advantage of the cheap compute costs on layer 2s to then expand this in the contract and actually perform the execution on chain. So another way we can save more data that's being rolled up inside of there. But it's not all rainbows and unicorns all the way down for us doing all of this. There are a lot of problems that you have to deal with and a lot of trade-offs for this. One of them is L2 compute gas is still not cheap enough for us to do some of these things in mass. And so we're seeing trade-offs where we're able to get the data size really low, but we're using so much compute inside of that that we still are getting roughly close to what a normal transaction would be. There are some ways we might be able to optimize this to find the right balance, but there's even the possibility, we haven't really looked into this, of using something like a ZKP for the BLS signature verification. One of the cool things about that would be because the computation and compression is built in, we can basically potentially verify these signatures for maybe fractions of the cost of what it's costing us in gas right now. And there's some, that's an implementation of the BLS 12381 curve as some CIRCOM circuits. So that's kind of one big one. Another one is smart contract wallets don't really have first-class support right now in a lot of apps. If you plug into them, there might be certain things that you just can't do. One of the big ones relates to ERC-1271, which is essentially a spec that allows a smart contract to verify the signature on a message. So you can imagine going into OpenSea, when you're trading NFTs, you actually do a signed message to send all of those. And so a lot of DApps don't really have support for having those contract-based signatures. So if you're a DApp developer and you want to allow people to use smart contract wallets with your app, this is a really good spec to support. And there are other things you can do to just test it out to make sure it works with existing smart contract wallets. And then the other really big hurdle is multi-chain issues with smart contract wallets. When you go and use these smart contract wallets, they have to be deployed and managed on each separate chain you want them on. We have ways of making sure they're at the same address, and we have making sure that they're relatively secure, those addresses where they're located. But you still have to manage all of that, and for a user, it's already difficult to know which funds are where with your Metamask account on every chain. What happens when we now have smart contracts managing all of this across those? What happens if one of your smart contract wallets is compromised? Are all of them compromised? If you rotate your keys via social recovery, you have to do it on every single chain. And so, right? So it's difficult, right? Just thinking about that. So there's issues around that as well, and making that easier for users and maybe having a more consistent cross-chain experience for those things. So these are all things that still need to be solved in meaningful ways. And there's a lot more that I did not list. But to kind of close with some final thoughts on kind of where we are with both those hackathons and with the BLS Wallet, standardization specs are making it way easier for people to build and adopt these kind of frameworks. When you have a spec to build towards, you can work within the bounds and take advantages of all those things. There are a lot more modes of authentication you can use to sign and do things than just private keys and seed phrases. We can use biometrics like fingerprints in your voice. We can use other devices and people, such as friends and family that you have, to recover your account as well. And this is probably more identifiable and more useful to most people than having to back up pieces of paper with seed phrases or remembering what device has what private key on it. And finally, we're using really kind of basic computer science methodology for scaling. We're doing things like trading space for computation with compression. We're doing aggregation or merging things in. And we're trying to take advantage of newer computational methods like ZKPs to scale this even further. And one thing I do want to mention too in regards to the layer 2 stuff, pro-dank sharding will probably be by itself even more effective than what we're doing now for lowering gas fees on L2s because of the reduced storage cross space on that. But I still think that the work we're doing on BLS Wallet can even take that further. So if we're scaling by, 2 orders of magnitude 100 times in terms of reducing gas costs, even if we can add 2 or 3 times on top of that, it could be a huge difference in terms of the amount of transactions these networks can process. Cool. Thanks for listening to my talk. You can find out more about BLS Wallet at our website, blswallet.org. The demo is currently broken. We're hopefully going to have it fixed before ETH Lisbon. We've had a lot of contract updates going recently. There's my GitHub link and all my contact info. Feel free to ping me or reach out if you have any other questions. Thank you so much. Cool. Questions?
Where does the signature aggregation take place? It is taking, so I have an application I'm supposing, the BLS wallet, and then there has to have a signature aggregation of multiple transactions has to happen, some from me, some from others. So is that happening on a server? Is that, where is, or on a smart?
It can honestly be wherever you want.
Okay.
In the case of the 437 spec, there actually is a function you can call that's a view function that will actually do the aggregation for you via like an RPC call or on chain. The way we're doing it right now is just in the clients. Our library has an aggregate function. You can take a bunch of different user ops that are signed and it just does the merge for you. So generally the merging is going to happen really though at this bundler or aggregator up here. So you're going to have a bunch of people send in their user ops into some sort of pool, and then that is going to determine which ones it wants to collect together and submit. And that's when the actual aggregation will happen.
Bundler will aggregate.
Yeah, in most cases, either calling that the function I mentioned, or just doing it itself, knowing that it has those BLS signed operations.
So what are you going to do about the MEV around the bundlers?
No idea. That's a different problem.
Yay, honest.
Most likely a structure will become a bundler as soon as this gains traction, right?
Yeah.
I would run my own structure pool if this happens.
Yeah, no, exactly. We're actually kind of hoping to some degree people take advantage of that. We definitely want to prevent perhaps like some reordering, and there's some other techniques that are still being thought out. One of them involves using Schnorr signatures, which my coworker Wansob is looking into, where you essentially can, at this like sequencer layer, basically provide a signature that guarantees that a transaction will be included at a specific index or specific sequence. But there are also some other ways you can game that. At the very least, it does provide some more guarantees in the ordering that you're going to be guaranteed. But there are some other trade-offs with that as well. But like I said, we're actually kind of hoping with this and even with the ERC-437 that like MEV bots and bundlers do pick all this stuff up, because then users can throw it out, and then they can just pick it up and run it on behalf of users. And they're basically just trying to figure out, can I run these operations without and make a profit off of it? I didn't go at all into gasless transactions or paymasters, but if you're interested in knowing how that could be profitable for them, I'd recommend checking that out.
How much can it aggregate before it loses the scale of being able to aggregate?
I have not seen any limits to the signature aggregation. Right. So to give an example, the last, we don't have any up-to-date gas measurements, but the last gas tests I did, I was able to fill an entire Arbitrum Go early block with 150 user operations that did an ERC-20 transfer. So I've seen, if you think about the validator network on Ethereum, there's like tens of thousands of validators. And in some cases, when they have the attestations for the confirmations on those blocks, there's going to be 10,000 validators that attest on that. And they're all aggregating into just one signature. So I think the scale is pretty much limitless in terms, or the limit has to be insanely high.
So the limit basically will be how long are you going to keep it open to bundle? How the time propagation that you would want to bundle it to?
Yeah, and it's honestly going to be like how much gas is available on the L2. You could easily, like I said, make bundles that are just, it's one transaction in an entire block.
So the ERC that you spoke about, 1271,
Mm-hmm.
Can you talk a bit more about that? Because it seems like without that, a lot of this is not really even practical, right? If as a smart contract, I cannot sign transactions.
You still can sign transactions. This spec is specifically for if you want to check that something is signed by a specific wallet. So there's still things we can do in terms of processing transactions that are signed with BLS signatures, but there's a lot of signing operations like sign in with Ethereum or sign in with, signing messages. There's like the little weird one where you test you're not a US citizen or something like that, right? So to support that and have the DApp actually validate those, you have to have the spec support so that you're not validating it against the standard ECDSA signatures, just those, but it's whatever signature scheme the smart contract wallet wants to use.
How far are you picking the BLS wallet that you?
Like how far?
How far are you picking it? For proof of concept only, or you?
So we have code available that you can try to use right now. We actually have had a couple people integrate it for certain things. We certainly, it's not, I would say, production ready yet. It's very close. I'm not sure, we have like a couple of last audit issues to do before we really consider it ready for that, and maybe a few other DevX things. But I mean, we have documentation. You can go in and pull it in and try it out right now if you want to. And if you run into any issues, our website, we have a Discord server on there as well, where we all, you can ask questions and we'll have answers, or we can help assist if you have technical problems. Cool.
That's the questions. One last one.
Yeah, one last one.
Where did you get that awesome t-shirt?
This was, I think, 21 ETH Denver, maybe? No, it was in remote then. Some older ETH Denver. Yeah.
Looks like a 2020.
Yeah, we'll have to go on Antique Roadshow and they can evaluate when it was from and what it's worth.
Because you've been to how many ETH Denvers?
I've been to every single in-person ETH Denver since the first one. And I've been to most of the remote ones as well. It's a fun event. It's grown a lot. Too much sometimes. Cool. Awesome. Thank you, everyone.
Thank you. Just last words. I wanted to thank Jake, who's from the Ethereum Foundation, for showing up. Tom of Network Zero VC for speaking and helping to organize this. Big shout out to Alpha Labs, our event host for today, and Julia, who is here. She's the VC at Alpha Capital Labs, so if you have things to show her, she's the person you bring. And then we'd also like to thank Francecso of ConsenSys. He's left, but for coming. So please join the Telegram, ETH65. That's ETH, ETH65, and you find it. That's the Telegram channel. We will have more events like this. I think our next event will probably be on Solidity, and I think we're gonna try to deploy a Google Cloud node sometime. So it should be fun. Okay, thank you. Food is ready at the back. We have pizza and wings. And please do something about the swag, guys.